if you're able to do the little dash symbols and all that with the typing it out. But that's gonna be your next step. Go ahead and explain what we just did.
All right.
AP Calc. All right, y'all. So it looks like we're at 11. So we're transitioning to my next period. So again, for those who still need support, the next time around is going to be Thursday. So drop by on Thursday. And hopefully everyone has their screenshot so we could get to work on the mini final. All right. Bye, pre-calc. See ya. Awesome. So let me just clear my screen. Hello, AP Calculus. Let me just open up a copy of our mini final. Or I'm assuming that's what we're here for. Yes, the mini final work. By the way, I haven't yet, so I see that it's Juan and we have Sophia. Welcome, y'all. I don't know of, oh yeah, and then Gracia. Gracia, are you going to be joining us from Zoom or just here? Oh, are you going to be joining the Zoom for the AP Calc for the AP mini final? Or are you going to just look, you could just look here as well, so I'll be projecting.
I'll go ahead and use your office.
Okay, so just like physical. What was that? Sorry.
Is it, I was doing your office hours.
Okay, perfect, right now. Yes. Oh, yeah, perfect. I don't know if you have a copy of the mini final or not, if that helps. That'd be awesome, and then just let me know what stuff you need to give you credit. So, yeah, thank you so much. Just making sure. Okay. Yeah.
So with CP 2.2, because it horizontally shifts to the
And since you're using cosine, right? And then give me a second, AP Calc. Since you're using cosine, cosine starts at the maximum, correct? And then goes down. So this shifted actually by whatever this number is. So if you're using cosine, that would be the case. If you were to use sine, well, sine starts at the midline, so sine would be here. But let's just stick to your cosine. I feel like cosine's fine. You have to figure out, and it's hard for me to see, but you're gonna have to make an estimate. It's between 2.2 and 3.3, but it's closer to 3.3, maybe like 3.0. It gets shifted to the right by about 3.0. And then we go from there. Okay. So let me go ahead and open up mini final. I'm assuming that's where we're at. Oh yeah, you probably also want to open up our AP Calculus Big Ideas packet. And yes, and I have not graded the mini final just yet. But let's see what questions y'all have. You know, I'm projecting this too, so. Let me know what questions you have. So this is for Juan and Sophia. If y'all can hear me, I'm like so sorry. Okay. So Juan and Sophia, I'm gonna write this in the thing. I don't know if y'all are able to hear me. But yes, AP Calc now in the house. Oh, okay. I'm just confused on how to start, what to do, like everything in general. Okay. Yes, we can hear you. Okay. So how to get started. Okay, cool. So basically you're imagining that you're a materials planner for some home improvement store. I don't know, just think of Home Depot. Your company is releasing a new line of these decorative windows, and it's your job to calculate the area. of the glass that will be needed. So basically, these are the different types. So there's a square window shaped window. There's one that looks like a diamond. There's this style. There is a circle window. There's a window that looks like this, and then there's a window that looks like this. So these are just different window style designs. So all the windows are horizontally and vertically symmetric. So as you can see, they're kind of just reflections of the first kind of this function here that's graphed in the first quadrant. It's basically like you're reflecting it over and over to create the symmetric shape. And then this one's for number 6. And they're each 2 feet wide and about 2 feet tall. They're about. So some windows have straight edges, others are curvy. The different window shapes are shown below along with functions. So this one has a function of y equals 1. This one has this function. And the function they're talking about is just right here in black. So it's just in the first quadrant. So this one would be here. This one would be here. And then what else? And they're measured in feet from their centers. So this is what we have. And your job is to produce a list of window areas for your supervisor. And you want to estimate them as accurately as possible along with your calculations to justify each one. Now, if we go down to the rubric, you're proficient if you get accurately at least 4 window measures and your errors is small, you show your work for your integrals. And if you want advanced, at least, and you have even less of an error, so you're more precise, you show your work for your integrals. So that's how basically the grading is going to work out for this. So that's the basic idea. So our goal is we need to find the areas of these windows. And some tools we have from AP Calc is going back to our big ideas packet. You can use, there's Riemann sums, right? You can estimate areas under curves by using rectangles, but you're not going to get precise, right? It's not going to be perfect. But this is a method. So one way is Riemann sums. Of course, if you use many rectangles, then yeah, you will get a precise estimate, but who has the time to calculate like 100 rectangles? So this is a method, but it's not going to give you precise measurements for your like manager or supervisor who need those window measurements. So that's an idea. Usually you want to use Riemann sums if you don't know how to find the area of something that's curvy. Next, we have integrals. So integrals, the way that we learn them, can be used to calculate areas under curves. One of them is using geometry. So sometimes you have an area that's like a triangle, or sometimes you can use the fundamental theorem part 2, which is when you find the antiderivative and you plug into that formula. So there's different ways. You could do it with geometry, or you could do it with fundamental theorem part 2. And is there a third one? No, I think those are the 3 different ways I could think of. Riemann sums, geometry, integral with fundamental theorem. So those are the different ways. So for everyone that's in here, how would you try to figure out the area of window number 1? How would we figure out this area for window number 1? And just shoot out some ideas. Like how would we find the area of window number 1, everyone, using what we know here? We have a function, but we also have a shape that is very familiar to us. And this is from Juan, Sophia, and Shannon, welcome. I'll put the question in the chat.
Ms. O'Donnell, you're muted. I don't know if you meant to mute yourself, but you're muted.
I think I did, but I was asking here in person. I had an idea. Sorry if there's something in the chat, but we're trying to figure out the area of this. Y'all can see me in the iPad, hopefully. I didn't pin it, but I'm on the iPad. Let me spotlight it. And let me stop my share. So, oh my gosh, it's doing that thing again. How do I minimize this? And it says I can't minimize it. Why does this happen? Oh my gosh. Okay, actually, let me just go back to sharing my screen. That right there is infinite Riemann sums happening on the screen. So anyway, I'm on the iPad. If you see me, I hope you all can find the iPad. It says users iPad 3. And the suggestion I just had from in class was we could find the area of this little square right here. So that's what we're starting out with. Now I was like, okay, what's the base? Base is 1. I know I'm in the way. And then the height, what would be the height of this square? Let's see, there's some stuff in the chat I did not look at. Okay, so Juan put 1, Shannon put 1. Do you agree with that it's 1?
Yeah, I'll be looking for you.
Okay, and then yes, because it says like y equals 1. Okay, cool. So let's do that. So the height of this is 1. So how will we find the area? So we got base, we got height. What do we do with those two things? Multiply them. Yeah, so multiply them. So 1 times 1 is going to give me the area, which is basically 1, right? Well, so we found the area of 1 box, I guess. But what's the area of the whole window? What do I do now? So it looks like this is 1 foot. I think it says measured in feet. So that's one of them. How would I find the whole window though? And we got multiply by 4. Yeah, because we have 4 of them, right? Let's multiply by 4. Yeah, so basically if this is 1 foot, then that means this is another foot. This is another foot. And your other foot. So it looks like measurement for window number 1, everyone, is going to be exactly 4 feet. And how we did this is we just used geometry. We used basic geometry. I'm going to show you how we could use the fundamental theorem as well, because you are also able to use fundamental theorem as well. And then for this one, yeah, so let's work on this, and I will put that way, I can help you out with this. So for this one, number 1, you go ahead and let's go what we did right now. So you probably helped me get that first time. And then now we figured out that since one of them is 1 foot, it has to be the rest is 4. I mean, the overall is 4, right? 4 feet. And then we'll move on to number 2. So in a second, I'm going to show everyone how to do this with calculus. And if you could copy it down, and you're going to put number 1, and you're just going to copy down like what I did in a second. Okay. So everyone, I'm going to go ahead and show us, I'm going to talk about how we could do number 1 with calculus. We just did it with geometry right now. So using fundamental theorem part 2. So how I shall do this is I need to turn off the projector, I believe. Or you know what? Instead of turning it off, I'm going to open a blank paper. Let me do that. That way I don't have to, I'll just go to Drive and open up something blank. That way I don't have to turn this off. Sorry, y'all, my stuff is loading. Okay, cool. So there's my blank screen. Oh my god. Okay. Yo, this is my life. Okay. Hopefully y'all can hear me, and we're looking at iPad number 3. There was just a little charting thing. I think everything's good. Okay. Okay, so let's talk about how to do number 1 using calculus. So number 1, we were given a function. I'm writing on this here board. And I'm just worried about this little glare though. No, I think y'all can still see it. So our original function was y equals 1. That was the function that just looked like a very, it was a straight line like this. That was y equals 1 for number 1. And in order for us to use the fundamental theorem of calculus, let me make sure if y'all remember this window, the first one ended at the x value of 1 and it had a height of 1. So when we are to set up the integral, we're going to make sure that it starts at 0 and goes up to 1 on the x-axis. That's finding the area. Starts at 0, ends at 1. The next thing that we need for us to fully complete fundamental theorem is the antiderivative of y equals 1. That's the tricky part. Now, what is the antiderivative of y equals 1? Would it be what? We'll have to actually figure out what is the antiderivative first. Yeah, so antiderivative. What is that? And as a little reminder for everyone who's watching, I'm checking the chat. The antiderivative is basically like you're asking yourself the derivative of what is going to get me the y value of what. We're trying to figure out what is question mark. And that's going to tell me what the antiderivative is. So I see 2 things in the chat. Let's see if anyone knows the antiderivative. Yeah, it's in a private message. But I wish you said it publicly. The answer here is that the derivative of x is equal to 1. So the antiderivative is x. And that wasn't a private chat, y'all, but it's there. The derivative of x gives me 1. So that means the antiderivative of the y value equals 1 is going to be x. Sorry. I'm just writing out my steps now so it's clear. Remember, step 1, antiderivative. Actually, usually my step 2, y'all, was I color-coded the lower and the upper bounds. But step 1, let's just say antiderivative, so we'll take care of that in a second. Step 2 is we need to put it in the f of b minus f of a style. That's what we're going to do next. And basically what that is, f of b is you're going to plug in the upper limit, 1 into x, minus, then you're gonna plug in the lower limit of 0 into x. That's what this is telling us to do. Basically plugging it into the antiderivative, then subtracting. And I'll check out the comments in the chat in a bit. Once I'm done, so I'm gonna plug in 1 into my antiderivative, that's 1. Then I go into subtract. Then I'm gonna plug in 0 into the antiderivative, so I'm doing this part. And I get that 1 minus 0 is equal to 1. So I simplify. Well, lo and behold, everyone, 1 is the area under the curve for the first quadrant. And ultimately, what you would do after this is multiply by 4, because you know you have 4 of these. So this, as you can see, gave us the same answer as doing it with the geometry way, which we did over there. This is the calculus way, right here. So let me pause for questions. Sorry for the messiness, y'all. I'm just pausing for questions, if there's any, or if it made sense. So calculus, this is with geometry, as you can see, the calculus gave us the same answer, but it's only for 1. You still have to multiply by 4 at the end to get the area for the whole window, which is 4 feet for number 1. And how about this? So, because I don't know if anyone has questions, how about this? If in the chat, so Juan, Jan, and Sophia, if you could put number 2, that means you're ready for me to talk about number 2 in the chat, and that would be great. Okay, we have ready, we got number 2. All right, it looks like we're set and we're ready. Cool, I'm gonna go ahead and erase the work here, and let's check out what number 2 looks like. Then I'll ask you all for some ideas on how we can solve it. Let's check it out. Okay, number 2 looks like this. So we have something that looks like a diamond, and we have this line right here, and we also have a function. So what are some ideas on how to find the area of this diamond looking like shape? Let's go ahead and put some ideas in the chat. So we have an idea there in the chat. Points or geometry would work, I think. Yeah, I mean, okay, want to go the geometry route, and then again, I could show you all how calculus looks like. What is a way we can use geometry? And then Juan put, we can use integrals, right? Yes, you can use integrals for number 2 as well. But you can also use geometry to solve. I had a great idea right here in the class, so I could share it with you also. In the class, an idea was the fact that, okay, this right here is basically half of this one. And we knew that this one was 1 foot. That means that this has to be 0.5 foot. That's an idea on how you could apply number 1. Oh, sorry, and I was on the iPad. In case for those who didn't see that. They said for number one, since we knew that the square was 1 foot, half of the square, 0.5 for one of the, one of the triangle looking things. So then similarly, what they can do is 0.5 times 4 to get the area of number two using geometry. So that's an awesome technique. Let me know if anyone has any other ideas on how they would go about finding the area of this. And or if you want to check out how to use calculus to figure this out. Why is this crooked? And then we have, so Juan says, let's do calculus since we have to do it for the rest. We'll need to do it for the rest. Okay, let's check it out. Let's try to do calculus. Okay, for number two. So again, you are able to find the area of this window for number two using what you know about geometry. You could also base it off what you did for number one. So if we do an integral, right, I know that it means I need to get basically 0.5 times 4. That would be 2 feet. So according to that, we should get an answer of 2 feet. So let's go ahead and check out if the calculus will indeed give us that. So let's see. So now I'm going to go back to my blank paper. And let's check it out. This time I'll try my best to be near. Let's see. Try different colors. Okay, so the new function is y equals 1 minus x. And its graph looks something like this. And we need to know the starting point is at 0. This ending point, I believe, was also at 1. So that means when I set up my integral, it's going to go from 0 to 1. So let me set up the integral, I guess, right here. The integral is going to go from 0 to 1. My function usually goes after the integral. The function is 1 minus x. And we usually write dx after it, the proper notation. Then we're going to start the first step. The first step is we got to find the antiderivative of this. So again, the question now is going to be, what is the antiderivative of this? Well, we know that the antiderivative of 1 already because we did that from number 1. We knew that the antiderivative of 1 is x. So then we got to just figure out what the antiderivative of x is. Let's see if anyone knows in the chat or in person. So that's our first step. We got to find antiderivative. Don't forget, y'all, we have a rule as well. Let me write down the rule. Super space. I wrote the rule down right there. So let's see if anyone has any ideas. I'll give you all some time to think. What is the antiderivative of that orange function that I've written? 1 minus x. If we need support, I just put, can we put a thumbs up? I can't tell if people are thinking or if we're just stuck, like, okay, we need some support. If you could put a thumbs up if you're able to on your thing, or just put need help in the chat, that would be great. That way I could know the support. Okay, I'm stuck. That will give me, yeah, that helps me out. Cause then it's like, if it was in class, I would be able to tell when we're stuck or if we need support. How do we find antiderivatives again? Okay, so let's do this. It looks like we need some support. So let's do it. So I'm gonna be on the iPad, everyone. So on iPad, take a look at the iPad on your Zoom. And yeah, I wish I could stop sharing, but whenever I stop sharing, that weird thing happens. Unless it's like I get it out the way somehow. But yeah, let's just keep it like that. Okay, so let's do this. So I'm on the iPad, and we're gonna figure out the antiderivative. And let me do it in orange. Here's my pens. Okay, so for number one, we have that the antiderivative of number one is basically x. We already figured that out from number one. Now I'm just going to bring down this minus. And now for this one, I'm going to be using the power rule. So remember the power rule says this is going to be x to the first. There's an imaginary little 1 right there. You see that? X to the first. We're going to apply the power rule. So 1 plus 1, that's 2. Then you're going to divide it by the very same exponent in your denominator like that. And that's your antiderivative, everyone. So we found this antiderivative from number 1. And this antiderivative, I used the rule. And I now have my antiderivative. Now for this, by the way, you could pull out the 1/2 in the front. So this could be rewritten like this. I like it like this, but if you want to keep it the other way, you could too. That is the antiderivative, everyone. And we better make sure that that's correct because we're going to verify if it makes sense. Like the area should be 2. 2 feet is what we should get for number 2 in the area of the window. So this is our antiderivative. Let's see what's in the chat, if there's anything. Do we need 2 for the final or is this optional? Hey, if you're able to find the areas without calculus, you're good. If you're trying to strive for advanced, yes, you want to, and in addition, as Juan said, you will need to do it for number 3, for question number 3. So you might want to know, you might want to see, how to do it so that you're not stuck when those do come up. But for number 2, if you're able to do it with geometry, you don't need to do it. Wait, how did it turn into 1/2 x squared? As I have as a question. So let me go back to what I had before. For 1, did it make sense how I originally had this? Did that part make sense? If I could get a yes or no. Yes. So how did I get this? X squared divided by 2 from the rule right here. So right here, this x to the first. In order to get the antiderivative, you got to do the exponent plus 1. That's how I got 2. Then you divide it by that very same number. So that's why I got divided by 2 right there.
So you add both of these together.
Yeah, so basically you add 1 here. That's how I got 2. And then you divide it by, you have that very same number in your denominator. So these two need to match. And then that's right there in the rule. And then there was a specific question. So basically this right here for 1, this is equivalent to writing this. That is equivalent to that. And the reason for why that's true is because, let me write it. Oh, you put, oh, right. It's equivalent. I just like, yeah, because it's like you're dividing by 2 is the same as multiplying by 1/2. Yes. That's why you can do that. So it's equivalent, but y'all can use whatever makes you feel comfortable. I just like pulling out that 1/2. For me, it's weird when it's below the x. So I rewrote that like this. So that is our antiderivative. Cool. That means we have our first step for the integral. Basically, this thing we just found goes right down here. So antiderivative. Remember, we're not done yet because that's not the only thing, right? We found the antiderivative, but we now got to plug into the f of b minus f of a formula, which is basically a story fundamental theorem part 2. And basically, my b is going to be 1, my a is going to be 0. I like zeros because then that means my work's going to be easy. I'm going to use black. So I'm going to plug in my 1 first into my antiderivative. That's going to be 1 minus 1/2, 1 squared. So I plugged in 1. That's me plugging in 1 into the antiderivative first. Check. Now we're going to subtract. And then we're going to plug in the second term, which is 0, into the antiderivative. And then that's check. Luckily for us, this is all going to be 0 because 0 minus anything times 0 squared is just going to give us 0. So that's going to go away. That becomes 0. So that means this is going to give us the area for that first piece of that window, which we know should be 1/2 of a foot. It looks like it will be though, right? According to this calculation. Let's simplify this. So we're going to get 1 minus 1/2 times 1 squared. 1 squared is 1. So then basically this is going to become 1 minus 1/2, which is basically 1/2. Notice how that gave us the, oh wow. Let's see if y'all can see my bottom. There you go. All right, shifted my iPad so y'all can see that. So as you can see, that reasoning was correct, where it's basically half of the window from number 1. But then we have to take 1/2 of a foot and multiply by 4 to get the overall area, which will be 2 feet for number 2. So see how it makes sense? The calculus is verifying the geometry, which is up there. Geometry versus calculus. So let me now pause for questions. If there are any. Okay, let's see. I see 2 stuff in the chat. Okay, so I still don't understand this. Can we get extra support? You said we would get 2 feet. Oh, yeah. So Shannon says, you said we would get 2 feet. Yeah, so for example, notice how the integral, I went from 0 to 1, right? That means I'm only finding the piece or the segment in the first quadrant. This part. I'm only finding the area for that. I still have to take my answer of 1/2 feet, right? I still have to, let me use another color, multiply by 4 because there are 4 windows. I still have to multiply by 4. 1/2 times 4 is going to give me an overall 2 feet measurement for the whole window. So you are still getting 2 feet. So the area of all quadrants together is equal to 2 feet. That is correct. Let's go back to the picture. And then yes, you could get extra support or feedback, of course, definitely. And especially if you turn in your work and whatever. So if we look back at number 2, so basically you're looking at my screen now. You're not looking at the board. So look at my actual. Let me now spotlight myself. So you all can see my screen, right? Number 2 right here that we're looking at. So for number 2, here are the different ways you could actually find the area. Right now, we just showed with calculus that this area right here was 1/2 foot. We are just shown that with the integral. I am right now back on my main screen, and I am drawing on the screen. We have found with calculus that this is 1/2 foot, but we are in a window store and we need to figure out the whole area of the window. And that's why you have to multiply by 4 because we only found this part. So that's why it's 1/2 times 4, which is 2 feet, right? Yes. 1/2 times 4 is 2 feet. So then we have, okay, let's see what's on the chat. We have, oh, and all quadrants are equal. I think I get it now. It clicked. Yes. And that's the reason why all the shapes in this mini final are symmetric. All of the shapes, and I think someone said it here when they were commenting, they said right here, look at James' comment, everyone. So if we get the answer of one side, basically one quadrant, like we just did with the integral, do we just multiply by 4? Yes, that is what we're doing because they're symmetric. So yeah, that's why I like how James mentioned that comment there. So that's what we're doing at the end of it. So that's why you only set up your integral from 0 to 1. You only care about one shape because then at the end of it, you just multiply by 4 to get the overall shape. So that's what we're doing. Let's see if anyone has specific questions though about number 2 that I can address right now. And if you need further support, definitely feel free to ask your questions. So basically, when you type up your explanation, the answer for number 1 we got was 4 feet. You could either use geometry to figure that out, right? Base times height. This is the area of a square or rectangle. It's a square. Base times height. You could use geometry, but you could also use the fundamental theorem of calculus, like I showed you before. Number 2, you could do it with geometry, or you could do it with the fundamental theorem as that's on the board that we did together. And number 3, though, y'all, I don't think you can use geometry for number 3. Number 3 looks particularly long. Look, it has three terms in an expression. So for this one, you're going to have to use the fundamental theorem. You won't be able to use geometry to prove your point. And then we don't need to mention the big ideas packet on the final, do we? I mean, I think for advanced, it would be great, even though I know it's not in the rubric. If it's not on the rubric, then y'all can still get advanced without it. But it'd be great if you could. But basically our main, like if y'all didn't notice, our big ideas packet is kind of smaller than usual. Basically because most of our focus for this big ideas is either the fundamental theorem of calculus and integrals. And lastly, there's Riemann sums. So basically it's small, it's not a requirement. So yeah, Shannon, you're right, but it would be nice if you could, but no, not a requirement, not even for advanced, if you could see at the bottom on the rubric. Great questions. Let's see, we're at about, we have about 13 minutes, y'all. What's another one that you'd like to ask a question, or do you want to get a start on number 3? Or if you have any other questions on any other ones that look probably funky, like 5 or 6. I could give a suggestion on how to get started, but not really how to actually fully finish it. How would we get started on 5 or 6? Yeah, okay, thank you. So, y'all, number 5 and number 6 look very funky, don't they? They do, because they have an E in it. And E is basically like a weird, it's kind of like pi. Number E is like pi, where it represents some number. So you have these funky looking functions. Unfortunately, we didn't get time to really talk about E and how to find the antiderivative of E. But if you want to try the fundamental theorem for 5 and 6 on these guys, I would go to our big ideas packet, and you would scroll all the way to the bottom of it. In the bottom, you have those rules. Y'all remember this chart? You could see that there's an antiderivative of E right here. So the integral of E is actually equal to this. So there is like a little formula for you. It's weird. The antiderivative of E to the X is actually E to the X. That's the only function whose antiderivative is itself. Notice how its derivative is also itself. It's weird. So E is a funny function. So here's my recommendation for everyone here. I do not recommend you using fundamental theorem for 5 and 6. Does anyone have any idea what we could use instead to make an approximation? Let's see if anyone knows here. How can we instead approximate 5 and 6? So not using the fundamental theorem. Riemann sums. Yes, that is how you can make an approximation. Not only Riemann sums, but you could also notice how number 5 looks very much similar to number 2. But you can tell that number 5's area is going to be slightly less than number 2. So you can use that to make very close approximations as well. But yes, Riemann sums is what I recommend for number 5 and number 6, because these are a little bit more complex, and we don't have an antiderivative rule for these more complicated ones, because there's more than just E to the X. There's like a different functions like happening around it. So I recommend Riemann sums. And if you have any other like ideas to approximate, like I said, notice how number 5 looks like number 2, but you know that the area is less, so you can approximate in that manner. So yes, Riemann sums for 5 and 6. So that's definitely key there, and that's why your Riemann sums is in your big ideas packet. Yes. And then it says for number 3, do we have to turn all 3 parts of the function into antiderivative? Yeah, we can't have like partial. So basically, yes, this is a long function. That means you have to find the antiderivative of all 3 terms. We know the wait, look, y'all, you already know the antiderivative of 1 from number 1. You know the antiderivative of X from number 2. So now you just have to find the antiderivative of the last term. So notice how it's kind of building up a little bit. Yes, that's correct for Juan. You put X, right? And so it's just 2x squared. Yeah, so from our prior work, we know this one, we know this one. Now we just need to figure out the antiderivative of the 2x squared. And you're going to be using the same rule that I put up on the board, the power rule. And I'll also write it on my screen. So the power rule, x to the n. The antiderivative is basically where you just add 1. And basically that rule is going to help you get the antiderivative of the last term. I don't know if anyone wants to like maybe try to figure out what the antiderivative would be if you're curious to check for that last term. But again, keep in mind, yeah, if I tried it, okay, what'd you get? You got 2x to the third divided by 3. That's correct. It would be great if you want to share that in the chat with everyone. I was trying to see, I wonder if I can copy and paste it. That's correct. That is the antiderivative. Yay, thank you, Juan. That is the antiderivative of that last term. Notice how he simply applied the power rule. The 2 just stays there. You basically just add 1 to 2, the exponent 2 divided by what that number is, which is 3. So it's 2x to the third divided by 3, the antiderivative for the last term. And can it be simplified to 2/3 x to the third? That is correct. That can be rewritten as, and let me do that part, 2/3 x to the third, which is what I like writing it like that. I like pulling out the fraction to the front. But you could keep it the way Juan has written it in the chat. Oops, I wrote it to just, let me write that to everyone so y'all can see what is equivalent. And guess what, everyone? So basically, I would like to get a draft. Everyone just go ahead and turn in a draft, get an attempt in, because in May, right, once this week is over, we're gonna go into mini modules and we're gonna go back into the mini final. We're gonna actually still work on this, but I do want a draft. So I want everyone to submit their draft so I can give you an initial score. And then that way, when we come back, you'll have some time to revise it even more. And then, okay, so when do you need our draft? By the end of this week would be great. By end of this week. That way I could grade it. Yeah, and then that way, you'll have something to work on once you return. So we have, some more time to work on this. All right, let's see if there's any burning questions. We have about 5 more minutes. If anyone needs me to do something or something that would help you out, that would, be awesome. Cool. And then we do 5 to get advanced. Yep, that's what it says here, at least 5 to get advanced. And it could be any 5. So let's say you don't want to do number 5 and you want to do number 6, you could also do that as well. All right, y'all, so let me know if there's any other questions coming up for us, but if not, feel free to get started on this. I think it's lunchtime, huh? 11:55. Oh yeah, I think it's time. All right, y'all, this was a great session. Again, if you want to reach out for like a one-on-one on this, definitely I'm available for, oh my gosh, was this recorded? I guess it is recording. I think, yeah, I'll upload this recording. I do not know how the video is going to look. Let's hope it looks good. But yes, let me try it. I think it's also going to include my period 3 too, though. Yes, I'll record this uploading to the best that I can, and I'll send it. All right, everyone, enjoy your lunch. If you need me for anything, just text or remind. I'm happy to also meet up if this wasn't enough as well. Bye, everyone. Good luck. Bye.